The correlation coefficient is independent of the change in origin and scale. This is what we have to prove. Suppose x and y, these are two variates, and rxy is the correlation coefficient between x and y. And suppose you define u. So what we have done is, and this is the new variate which is corresponding to change of origin and scale. Okay. Similarly for y we define v, the change of origin and scale. Okay. Of course assuming h greater than 0 and k is also greater than 0. Okay. Now you can write this as x is equal to a plus hu, and from here you can write y is equal to b plus kv. Is that right? So you can write x bar equals to a plus hu bar and y bar equals to b plus kv bar. See, you will be putting this bar only on the variables, not on the constants. B, K, H, A, these are all constants. So, well, in case if you write x minus x bar, what will you be getting as h u minus u bar, and y minus y bar is equal to k v minus v bar. Is that right? Now what you can do is that you can write the formula for the correlation coefficient between x and y, which is the covariance upon covariance of x and y upon standard deviation of x into standard deviation of y. So covariance of x and y divided by standard deviation of x into standard deviation of y. So covariance of x and y, it could be written as E of x minus x bar into y minus y bar divided by standard deviation of x is given by E of square root of the variance of x, which is E of x minus x bar square, E of y minus y bar square. Is that right? So what you can do is, how will you write x minus x bar? As h into u minus u bar. So E of h into u minus u bar into, in place of y minus y bar, what will you write? K into v minus v bar, and you have to take expectation of this whole upon divided by, in place of E of x minus x bar square, what will you write? E of h square into u minus u bar square into E of k square into v minus v bar square. Once you simplify this, what will you be getting is hk E of u minus u bar into v minus v bar whole divided by root of h square k square into E of u minus u bar square into E of v minus v bar square. Again simplifying this, what we'll be getting is hk into, and upon root of h square k square is just hk. And if you look at this this expression, which is E of u minus u bar into v minus v bar upon root of E u minus u bar square into E of v minus v bar square, it is nothing but the correlation coefficient between u and v. Okay, I should write it properly so that you can recognize this. This is u and v. Okay, so what you have is basically what you have proved is that r of xy is equal to r of u v. So what you have shown is that this correlation coefficient is independent of the change of origin 1, and it is also independent of the change of scale 2.